Well, thank you. Nice to see so many here this evening. Today we're going to have something really interesting. But before that, I'm just going to go a little bit over what our community is about and how you can also find more interesting events like this that we host. So yeah, as Michael mentioned, we are the DevOps Skåne community. And the agenda for today, well, we had the meet and greet. We're going to have a very nice presentation soon. And this evening, we're also going to try something that we haven't really done before. And that is, we're going to have the pizza, of course, and the drinks. So that we're not going to change. But during that, we will also have some opportunities to have discussions on some topics that Lars will present in the end. So if you want to join these discussions, feel free. If you want to just want to eat pizza and have some drinks, you can do that too. It's fine. It's your choice. So yeah, our community, we have a group on LinkedIn that you're very welcome to join. We also have a GitHub page and a Discord. So if you would like to join any of these, you can just feel free to speak to me or to Evelina, who's also here today. Usually we post all of our meetups in those locations, or at least in LinkedIn and DevOps and the Discord. And yeah, this is then us. So yeah, Frederick is me, and we have Evelina here as well today. And we also have Albert as a co-organizer. We've been since 2018 a group and a community, and we're closing up to soon 60 meetups in total. So it's really nice. And I also want to just ask this question, because I always forget it. We usually want to take some photos of these events and post them in like LinkedIn and other maybe social media. So is there anyone here who doesn't want to be in a photo? Please raise a hand now. All right, good. And yeah, that was my 2 minutes of fame. So over to Lars. And yeah, also please give him some hands.
Thank you. Let's see if it works. Cool. Yeah. Branching considered harmful. It's work that I'm doing together with Brad Appleton and Steve Burchuk. So they are two of the authors of a seminal paper on branching strategies, streamlined branching patterns, that they wrote almost 30 years ago. And I got the idea that after 30 years, maybe it needed a slight update or an extension. So I approached them and pitched my idea, and they were in on it. And I think that maybe they see that it took a slightly different turn than what they had expected. So we're not really extending the paper that they wrote on branching patterns. We are probably digging a little bit more into what is at the end of a branch. So thank you for coming today. So there are probably two groups of people in the audience. Those who hate branches and come here to hear why they are right in hating branches, and then there's a group of people that love branching, and they are curious to find out why someone could consider branching harmful. Are there any Git users here in the audience? Oh, so you're the schizophrenic ones. So you love Git. Git is easy on branching. It's so easy to branch, so you love branching. And you love it so much that when you're done with a branch, you hate it and you delete it. Go figure. And then there might be, except for you, there might be 1 or 2 people here that just came for Malmö's best pizza and free beer. And if you want to know where the pizza comes from, you can ask Mika. If you came for the pizza, you have to sit for 45 minutes and wait and listen to me. So why is branching harmful? Well, at the end of a branch, there is a pot of gold, or there should have been a pot of gold. Unfortunately, there is a merge. And the merge is really what often causes pain. But since I consider a branch and the use of a branch and the termination, the merge, as one thing, then I say branching should be considered harmful. So we'll probably dig a little bit more into the merging thing. There is a price to pay. How much will it cost to merge a branch? Who will pay that price? And we'll look more into merging and merge conflicts. Why do we branch? Why do we branch? If you're Git users, you know the answer. We branch because it's so easy. We don't know why, but it's easy, so we just branch. Well, the real cause why we branch is because we want to allow parallel work, allow people to work in parallel. And when we work in parallel, we want to have isolation. So you want to be isolated from my changes, and I want to be isolated from your changes. So you work on your branch, I work on my branch, perfect isolation. He doesn't bother me, and I don't bother him. That's the solution. And basically, what we are addressing is Wayne Babbitt's shared data problem. Wayne Babbage is the god of software configuration management. He discovered and described the 3 coordination problems that all teams that have to collaborate, that they encounter: the shared data problem, the double maintenance problem, and the simultaneous update problem. He did that at the beginning of the 80s, and these problems are still around. And they will be around also after generative AI has tried to solve the problem. So branching isolation is sort of a solution to the shared data problem that will allow us to work smoothly in parallel. So you don't disturb me and I don't disturb you. Problem solved. Unfortunately, this isolation creates copies of the code. You have a copy of the code, I have a copy of the code, and that is the double maintenance problem from Wayne Babbage. And we have to sort of address that problem and try to keep these copies of the code in sync. So we address one problem, the shared data problem, and we get another problem, the double maintenance problem. Let's see how we can try to manage those without things becoming too painful. Now, how many of you have read Wayne Babbitt's book? A couple of people. So, what does Wayne Babbage say about the double maintenance problem? So, he has a copy of the code, I have a copy of the code. Now we have 2 copies. He says that if a bug is fixed, then it must be fixed in both copies, and not just in both copies, but it must be fixed identically. So if you fix a bug, the bug is also in my code, and the bug should also be fixed in my code. Could you please do that? Well, even if you're nice and you might want to fix the copy or the bug also in my copy of the code, then this is obviously a solution that doesn't scale. So if we don't do that, then these copies, they will diverge and they will not be identical anymore. Wayne Babbage also says that with time, if we don't do anything, these things will diverge and they will grow apart. and maintaining them sort of identical will become more and more difficult. So the first principle of configuration management for Wayne Babbage back in the early 80s was to avoid multiple copies of the same information. So trying to avoid the double maintenance problem. Does that sound good? Well, you can't have a copy anymore. So the situation that Wayne Babbage was in the early 80s was that version control tools were not widespread. So you had a copy of the code, I had a copy of the code. If you made a bug fix, we had to find some way to make your bug fix come into my copy of the code. Without the help of Git, I mean, probably Linus Torvalds wasn't even born in the early 80s. So we had to do things manually. And that's why Wayne Babbage says we should try as much as we can to avoid the double maintenance problem. These days, the double maintenance problem is no big deal. So you know how you can get my bug fix, and I know how I can get your bug fix, and it's all automatic. They diverge. We have the tools that can help us to sort of bring them back together. The merge tool. Let's see if I can have this small video. Yeah, this is a merge.
I feel like I'm back at the office now.
Isn't it nice?
Can you fast forward a bit?
No, but for the benefit of people with traumatic merge experience, I will run it again. This is how it looks when our students on the agile projects experience the first merges that they have to do. Very traumatic. Is that what you would like a merge to be? Painful? No. Let's see what we can do to avoid getting in that situation. So the price of a merge, what is the price of a merge? There are three possible merge outcomes: the good, the bad, and the ugly. So let's try to see what the good outcome is. The good outcome is actually that we have a textual conflict. If we have a textual conflict, it's evident and you see it and you know that there is a problem and you have to address it. If there isn't a direct conflict, there might be something lurking beneath the surface, and when you least expect it, it'll hit you in the neck. So the good outcome is that we have a textual conflict. One of the bad outcomes is that we have a textual merge, and the merge tool says, yeah, I did it, no conflicts. Do you believe the merge tool? No? Well, and the ugly outcome is that the merge tool says there was nothing to merge. So you changed the file foo, I changed the file bar. We changed two different files. The merge tool says there's nothing to merge. What's the problem? Don't worry, be happy, smile. We are home safe. So merge and merge. So actually, there is a merge going on here. But it's not the merge, the traditional merge tool that takes care of the merge. The merge, in quotes, is that your version of foo will be merged into my system, so I will now have your version of foo and my version of bar. And that can create an indirect conflict. even if the textual merge says that there is no conflict, I managed to merge these things. Maybe the changes you made in the beginning of the file doesn't really match with the things that I made at the end of the file. Textually, the merge tool will merge them in. But maybe you removed the declaration of a variable, and I saw that it was there, so I used it in the method that I implemented at the end. But now the syntax and the semantics, they doesn't match anymore, and we have a problem. But the merge tool said that everything was okay. Or nothing to merge. Well, his bug fix touched one file. My new feature touches some other files. Well, the merge tool says I don't need to merge anything. The version control tool will do sort of a system merge and integrate his change to one file with my changes to another file. And it says, okay, there are no conflicts. Do we trust it? No, we shouldn't. So we can have these false positives, and it can give syntax errors, semantic errors, there can be logical errors, there can be dependencies. So there's a new version of the library. Is it backwards compatible, the new version? Maybe not. If it's not backwards compatible, then maybe my stuff doesn't work anymore. But it says that there is actually no merge. So since we don't trust this merge tool, we need to check up on it. So we need a process. Even if we are agile DevOps developers, sometimes we need a little process. We need a little discipline. So the merge process is a multi-stage thing. So any sane and secure merge is multi-stage. So first we do the merge. It could be textual or it could be on the system. Then we build the system. Does it still compile? And then we run the test. Does it actually still work? Does it pass the test? Does your bug fix work together with my feature? And we have always to do this. Never trust the merge tool, never trust the merge, always check up on it. In the good occasion, you'll get a merge conflict and you know you have to do something about it. But we have to check, does it build, does it pass the test? Because if it doesn't, then we need to do something. At least before we do a release. But the sooner we can catch this, the better. Insanity. Well, according to Albert Einstein, the definition of insanity is that you're doing the same thing over and over again, expecting to get different results. I have a slightly different interpretation in this context of insanity. Insanity is to continuously have problems with branching and merging and doing nothing about it except from cursing and hoping for a miracle. So let's see if we can do better than cursing and praying for a miracle. Sane merges or sane ways of using a branch. So what can we do to bring down the merge cost? Well, the direct conflicts, we can look at how we solve these direct conflicts, and we can look at what we could do to try to avoid that these textual merge conflicts, they arrive. So for the conflict resolution, who should resolve a merge conflict? Sorry? So we should do it together? Well,
The last sucker.
when I ask my students, they always point at someone else and he should do it. So I don't want to solve the merge conflict. But actually, the person best suited for solving a merge conflict is the person who created the merge conflict. Who created the merge conflict? You did.
I always do.
Yeah. So
It's not one person. There's at least two persons.
you did it, and I did it, because we were two to create this merge. Because you changed something, and I changed the same thing. Now I sit with the merge conflict. Because you were faster than me, so you left the job to me. But I should be competent in solving the merge conflict. First of all, the merge conflict is there because I have changed that part of the code. So it means that I've been working with that part of the code, and hopefully I know what I'm doing. Okay? And second of all, I get the merge conflict because I have recently worked with this code. So I can probably still remember what I was doing and why I was doing it. So the person who created the conflict, do you want to do it? No. Then I have to do it. So we are two parties, and the one who is the slowest will sit with the merge conflict and will be a competent person to solve the merge conflict. When should a conflict be resolved? Well, as soon as possible. As soon as possible, how often is that? How often do you think that we should? Yes? Multiple times a day? So I've seen solutions that actually worked, that goes from the two extremes were every 10 minutes, because there was a lot of people working on very little code, which meant that they were stepping on each other's toes, which meant that they had to synchronize every 10 minutes to not create very huge and complex merge conflicts. And I've seen other examples where, what are you working on? Oh, you're working over here in this part of our huge code base, and I'm working here together with the rest of the team. He can work for 3 weeks without the risk of being that there is a merge conflict, because you're the only one that works in that part of the code. So it sort of depends on how many people are working together on the same parts of the code.
If it's where you can work for 3 weeks without it being a problem, then it's also not a problem to do the work, then you might as well do it every 10 minutes.
We could still get some dependency merges. Yeah.
There's still a cognitive load, so therefore you should kind of mentally finish something in your...
I know that there are people that sit on the code for weeks and weeks before they sort of finally decide that they want to deliver it. I would prefer to sort of get it over and done. But if it takes 3 weeks to get it over and done, then I'll be working for 3 weeks and hopefully not disturb other people. I think some of the discussion, that there will be pizza at a certain point, and I've been told that I have to finish up my presentation before that. So how do we keep branches in sync? We do continuous integration, and continuous integration has to work both ways. Both that we have to continuously integrate into our workspace, so I will keep in sync with what you're doing and with what you're doing and with what you're doing. But I also have to allow you and you and you to keep in sync with me. So I also have to upload to the central repository the changes that I'm doing.
That was my question, what is some kind of messaging system that do a change, another person see your change and they can accept it, or let it be and bring their own change, and then you have to decide between which change is the best.
Well, if I'm doing a change, you don't have a choice. You have to accept it. I put it up into the repository, and it's there, and you will have to accept it. What about pull requests? the person who created it. The person servicing a pull request, did that person create the potential conflict? Usually not. When should a conflict be resolved? As soon as possible. How long will the pull request be sitting before it gets serviced? Nobody knows. When Linus Torvalds has time to service it, he will service it. It might be tomorrow, it might be next week, or never. So, time and who will show you. Which is why sometimes for pull requests, at least if it is Linus Torvalds, if he applies your pull request and gets a merge conflict, if he's in a nice mood, he will notify you that there was a merge conflict and rework your thing and send another pull request. If he's not in a nice mood, he'll just ignore. Because basically, he's not been involved in the merge conflict, and he's not very suited for handling it. And the time, if it takes 3 weeks before his time to service the pull request, then the possibility of a merge conflict will be higher. And that goes for disobedient people too. And you were not disobedient because you were very quick at uploading your changes, so you gave me the possibility to get the merge conflict. But if you're sitting on your code for 3 weeks before you want to integrate, then I'm quicker than you and you'll sit with the problem. How can we avoid direct conflicts? Why do we get a direct conflict? We get it because you and I are working on the same piece of code at the same time. So what can we do to avoid that? Locking? Why not? Why isn't locking not the good solution to this?
You would have to lock the whole repository.
Well, if I just lock the single file or the single files that I need to change,
But that's not safe because related functions.
that is not safe because we still have the shared data problem. As soon as I unlock my changes, then you'll be hit by those. So locking is not really a problem. In some But that is exactly what we try to obtain with the locking. And in very, very few cases, it is what we want to. If we don't have a merge tool that can merge parallel changes together, if we are changing a JPEG in parallel, then we have a merge problem because the merge tool doesn't know how to merge it. Then, oh no, Git doesn't have locking. We're fried. Then we need to figure out something. But locking is not really the solution. Impact analysis and scheduling. Trying to figure out who is working on what. So you have to fix a bug. What files do you need to change? This file and that file. I need to implement a feature. This feature will touch on this file and that file. That are completely different sets of files. Means that it's safe for us to work in parallel. At least we will not get any textual conflicts. So trying to get some impact analysis and try to schedule some things. So you and I need to work on the same file. There's a central file that both you and I need to change.
I'll always let you do it.
You'll let me go first? Okay, great. When I'm done, I'll notify you, and then you can pick it up, and you can continue on that. So impact analysis scheduling. Communication. Have you tried communication?
I was just going to suggest it, actually.
That's-
Perhaps actually.
That's so old-fashioned, but it still works. And knowledge of the hotspots. So I've seen systems where usually a file get to version 2, 3, or 4, and 1 or 2 of the files in the system gets to version 157 or something like that. because it's a very central thing that everyone needs to change when they change something. And that's a hotspot, and we should really try to coordinate, communicate maybe about that. We need a coffee machine, and we need to drink some more coffee, and we can talk while we are drinking that. And then there have been some research prototypes that sort of can look into what people are doing in their workspaces and try to sort of predict if we are sort of working on the same things. And also if we have indirect conflicts, that your changes something that I depend on. And they can sort of see what you're working on, what I'm working on, trying to put it hypothetically together and see if it might create a problem. But apparently it hasn't caught on. So we are stuck with the impact analysis and scheduling and communication and knowledge about hotspots. What can we do to bring down the merge conflicts? What about the indirect conflicts? Well, discovery is a very important thing about this, avoidance or preventing these indirect conflicts, and proactive discovery. So, textual discovery. The indirect conflicts for a textual merge, that the changes you made in the beginning of the file doesn't work well together with the changes I made at the end of the file. How do we discover that? Build and test. Well, the fact that your changes in one part of the system with a bug fix doesn't work together with my new feature that changed another part of the system. How do we discover that? Build and test. My students, they love when different questions have the same answer. Then they have to memorize less things. So if it is in the same file, communicate, or an old tool like CVS had a command called editors, so you could actually see what other people were editing. So I could see, oh, you are also editing foo. So do you want to have a coffee? Yeah, then we can talk about it. What are you changing in that file? And when will you be done with that? So I can maybe take over. So it's not exactly locking, but it's sort of creating awareness of what other people are doing, creating sort of a communication, modern communication. Sorry?
As coffee isn't that just locking, but softly and non-controllable?
Well,
Worse ways of doing locking.
it's soft locking. It gives people awareness. It gives people, then they will suffer the problems. We can also work on the architecture and the design to work with baselined APIs. Why should they be baselined, the APIs? Because if an API is baselined, it means that it will not change unless there is a change request that has been through a process, it has been accepted, and before integrating the changes into the API, everyone that depends on that API will be notified. So you have had an email about these changes to the API. I hope you read it. Split combine. So we can also split it up with these APIs, the front end and the back end. Whatever you're doing in the front end doesn't have any impact on what I'm doing in the back end, and the other way around, as long as we keep the interface between these two baselined. Strict long transactions. What are strict long transactions? Strict long transactions is a mechanism that is implemented in Git. So Git supports strict long transactions. Strict long transactions means that actually no sane person would textually merge into the repository. The normal traditional merge operation takes something from the repository and merges it into your workspace. Never, ever the other way around. Why don't we want to merge into the repository? These are some of the questions that I ask at my exam on the configuration management course. Because sometimes we get a merge conflict. And if we get a merge conflict, does the system work? No, it doesn't even compile. So if we merge into the repository, we don't know whether the repository will work. No sane person should logically merge into the repository. So if you have changed foo and put that to the repository, and I have changed bar, and if I put that to the repository, that will be a logical merge into the repository. It will be the first time in human history that your version of foo together with my version of bar exist. Since it's the first time in human history, has it been tested? No. This is a situation that scared the hell out of Linus Torvalds. He was freaking paranoid about the situation, so he implemented a mechanism that said that if you're not up to date with everything in the repository, you cannot push anything new into the repository. No sane person should logically merge something into the repository. Many version control tools, they will allow you to do that. And I've been told that there are a couple of tricks in Git that will actually create that too. So if you cannot merge, it means that I have put up a new version of bar. You're not up to date with the system. Now you have to take down the new version of bar. You will have to build and test and verify that everything works perfectly. Now you have the latest and greatest version of the whole system. Have you tested it? Does it work? It's got your name to it. Now you can take this sort of version, this configuration of the system, and put it up in the repository as the latest and greatest and tested and verified. And this is the way that we should work. Linus Torvalds forces us to do that. Other tools, they say that you need to implement some manual discipline to get it. So these strict long transactions, plus that you build and test when you get something new from the merge from the repository. Proactive discovery, so actually trying to hypothetically put your changes and my changes together, even if they are not up in the repository. They're just in our workspaces, and see, does it still compile? Does it still run through the test and stuff like that? So prevention is a good thing. So I can try to glue back together my wife's broken Moomin mug, but it'll probably be a whole lot cheaper if I avoid breaking it, especially if it's my wife's Moomin bug. So, and the same goes for the software code. It's a lot cheaper to sort of prevent and discover these merge conflicts early on instead of trying to fix it. Insanity, according to Einstein, doing the same thing over and over again. According to me, continuously having problems with branching and merging and doing nothing about it except from cursing and hoping for a miracle. Now, maybe you believe that all these problems about branching and merging, and that's only my young, naive, innocent students that experience these problems. Have you experienced it too?
I haven't.
Oh, you've been a young, naive student too. Or, yeah. So let's try to look at some data from real life. out there in industry. Research papers that have looked into the practices and data mined numbers out from real life. Branching and merging, the frequency of branching. Developers answering frequently or always to the question, how often do you branch? 80% do it frequently or always. Frequency of merge conflicts, frequently or very frequently. 40% of developers have experienced that frequently or very frequently. Rarely, only 16%. Other studies, they show that between 7 and 20% of the merges, they have a conflict. They have a problem. That's quite a high percentage. This is data from an American company. They have some domestic releases and they have some international releases, and they have 1, 2, 3, 4, 5, 6, 7, 8, 9 releases going on in parallel that they have to try to maintain. So changes from this one, some should maybe propagate to some of the others and the other way around. So when I see a figure like this one, I say, don't ask me how you can fix that situation. You should ask yourself, what brought me in this situation, and try to fix that. Because trying to sort of be able to promote a bug fix from here to there and there it's not working. Reasons to branch, when they ask developers, then 86% of developers say that they branch to have new features. 74 to fix the bugs. Apparently 35% of the developers, they don't have a repository that is releasable, so they need to create a release branch to put the final things right before they can actually release. And apparently also 35% of the developers, they are not able to test their own code. So they have to create a branch, and then probably someone else has to come in and pick the code from the branch and test it and verify it, and maybe someone then, when it has been verified, should merge it down to the main line. The bad and the ugly. Doing refactoring on a branch, 42% branch to do a refactoring. That is real insanity. How many files were you changing for your bug fix? 1 or 2 files. How many files will you change when you do a refactoring? A huge number. And you do it on a branch. And the branch is isolation. And if we don't continuously try to integrate, which usually you don't because you are very busy doing this huge refactoring, and it takes like 3 or 4 weeks before you're done. And then in one go, you upload a huge amount of code, reformatting the code, tasks that are not scheduled properly, also creates a lot of problem. Our students, they do this one once, and then they learn, and then they try to avoid it, and then they know how to do a refactoring. They do it step by step. It's a little bit like how you eat an elephant. You do it bite by bite, and not in one go. They do not communicate, create awareness, and in this company, the integrators were doing the merges, so we are back to the pull request and all the problems that we have there. Reasons for conflicts. I have to hurry up now, I can see. Branch duration, lack of communication are the 2 big ones. The number of changed files also have an influence, and the number of developers working in certain parts, in the same part of the code, also has some influence. But the branch duration and the lack of communication are the two big ones. There are a lot of branching anti-patterns. There are a lot more than those that are in the streamlines branching pattern paper, and branch a hull. That's what you hear in American court movies. Drinking may be considered harmful for pregnant women and young people, and in excessive quantities. But in certain circumstances, for certain people, like now that we're going to have pizza, a beer would be nice, and we can handle it. So how can we make branching less harmful, just like in some occasions we can make drinking less harmful? What was it that Wayne Babbage said about the double maintenance problem? He said that it must be fixed identically in both copies. We got merge tools. Wayne Babbage didn't. So, done. With time, the multiple couples will differ more and more. Time is the crucial word. So, try to do continuous integration. Try to fix this as soon as possible. Before their assumptions and understanding of the changes fade, merge your own code. Don't let other people merge the code. They will not be the right people to do it. Branching patterns. Activity branch was what they came up with 30 years ago. That will probably be called a feature branch or a bug fix branch. Development line is the main line, maintenance line, and release line. I think that the important thing is the code policy. That we should not create a branch without giving it a policy, a reason. Why do we create this branch? If there's a reason for it, if you can justify it and motivate it, then by all means go ahead. Is it an activity branch? Is it a feature branch? Or is it a release branch? If it is a release branch, then we have described how we should work with the release branch, how often we should integrate, what we should integrate. Should we integrate things from the release branch to the main branch? Maybe yes, maybe no. Maybe parts of it, but we need a policy for that. Not anarchy and chaos. Takeaways. Last time I was here talking about software configuration management, someone mentioned at the end, this is common sense. And I said, yeah, it's common sense. But as you've seen with data from real life industry, it seems that they're not using as much common sense as they could. Some companies and some development teams, they do it. Branches are like fire. They're good when they serve you, and they're bad when they master you. So try to be in command of your branches. Branching is cheap. Merging can be very costly. So long-lived isolation is the real problem. And that is what we have to address. Conflicts. But the indirect conflicts are sort of invisible, which means that they are more dangerous. And the build and test, the merge process, will make sure that we discover them as quickly as possible. And branching is not a hammer, and all problems are not nails. Further reading, chapter 1 in Wayne Babbage's book about the coordination problems that teams have, and the streamlines branching pattern paper from '98 that you can go on to the website. And the most important part of this paper is not like the 50 or 60 different branching patterns that they define. It's the first 20 pages where they analyze and discuss the forces of branching. Safety, liveness. We want to have safety for our branch. So if we're working on the main line, safety on the main line means this feature that you're implementing now, do we want that to go into the next release? Maybe. If it is something that maybe we want to postpone it until later on, we don't know right now, do we want you to integrate that feature into the main line? If we're so mature that we're able to handle feature toggles, then we can sort of integrate it into the main line. If we're not, or if we don't want to use feature toggles, then maybe we should put the feature on a branch. Then it sits there, and if we want to have it into the current release, then we can merge it down. If we want it to be in the next release, then after the release, then we can merge it down.
Feature flagging is also just branching the code in your verification. So it depends on where you want the hit. Maybe sometimes it's easier to handle when it's not together.
Yeah. Yeah. So Mika is stressing me. So let's see. We're having pizza now, and DevOps Corner, they want us to talk with pizza in our mouth while we're chewing on the pizza. So there will be some discussion questions. Basically, a branch is isolation, a workspace is isolation, so a workspace is actually also a branch. Should we treat them differently, or are there some similarities, and how should we go around it? Does it depend on whether it's a distributed or a centralized version control tool? What are the alternatives to branching? What is the cost of not branching? Can trunk-based development be made to work? What does it require? What are the advantages? What are the risks? So there will be some tables, and there will be these discussion questions, and you can sort of get together with people that want to discuss the same thing as you do. And I will float around. Thank you.